there is no carry. Next case 2. Case 2 is, suppose 0, 1. 0 plus 1 is what? Sum is 1, there is no carry. So for the first step, that would be the status of sum S and C out. Suppose if my previous carry is 0 now, what will happen? That will be trying to add with this. To which one? Sum bit. So 0 plus 1 is what? 1. And C out is 0. So this is the status of my sum and carry. If suppose my previous carry generated is 0 now. Suppose if for the same case, if previous carry generated is 1, what will happen? What will happen? If there is a change in the previous carry, if it is 1 now, what will happen? 1 plus 1 is what? You know the normal addition. The carry bit would be generated and sum would be 0. So there is a change. Okay? Because you know the digital addition is what? 1 plus 1 is what? Sum is 0 and carry out is 1. So, okay? So here the data will be what? For the next case, 1, 0. If previous carry is 0. So first it will perform the addition of 2 bits. 1 plus 0 is 1. 1. No carry. 0 plus 1 again 1. So there is no change. For the next case, for the same case, if the previous carry generated is 1 now, what will happen? First it will make the addition of 1. So what is that? 1. And then what will happen? Carry, there is no carry at that time while adding A and B. Wherein after that the previous carry would be added with the sum bit. So 1 plus 1, what will happen? Again you will have 0 back. Am I right? Next, finally you will have these two cases. If previous carry generated is 0 now, what will happen? And 1 now, what will happen? We will see. So 1 plus 1, what again? You know 0, 1. So for the initial addition itself, sum is 0, carry is 1. Again sum and sum would be, sum and previous carry, if it's 0 now, what will happen? 0 plus 0 is again 0, so there is no change. The same case, if the previous carry is 1 now, what will happen? So first, it will perform the addition of A and B. What is that? 1 plus 1 is what? 0, 1. Sum is 0, carry is 1. And again this would be added with the previous carry. If the previous carry is 1 now, then 0 plus 1, there is a change. What is that? It's 1. So this is how the truth table arises. So you can check it with your book. Okay? So you should not just by heart and write it. You have to process and you have to plot it. So if you are making use of your pen now, kindly make use of a separate space to make the addition and to perform here. Okay? For exam point of view, you can come prepared with this by heart. Next. Now the truth table has been plotted for your full array. Next comes is your K-map, because I want the expression. If I need a circuit now, for that I need a SOP form of simplified expression. So an expression could be obtained from the truth table with the help of your Karnaga map. K-map. So you have various types of K-mapping, 2 variable, 3 variable, 4, 5 and so on. So you have to look into what structure I have to choose. So you have to look into the number of inputs. These are the inputs A, B, C, N. So which is of 3 variables. So you have to go for 3 variable structures. Okay, I identify. How many structure I have to plot? Based on outputs. How many outputs? Sum, carry out. So how many structures you have to draw? 2 structures. 3 variable K map structure, 2 you have to plot. So that you can have the expression for sum and carry. Okay. So to obtain sum, what is the structure? 3 variable structure. 3 variable structure, as I taught you, this is the structure of of your banana, and these things you know already. You can take any variable at any side, like A. If you are starting like this, like A, B, C, N. A could be either 0 or 1, and the possible combination 0, 0, 0, 1, 1, 1, 1, 0. Do remember, while writing on the top, the columns has to be always 0, 0, 0, 1, 1, 1, 1, 0, because only single bit change is allowed. No 2-bit change is allowed. Because 0, 1, it is a spontaneous thing that you will be starting with 1, 0. 1, 0, there is a 2-bit change, which is not allowed. Okay, I gave you the reasons already. So now the value of cell is what? This cell is what? 0, 0, 0. So that means what? What is the name of this cell if I want to name it now? This means A bar, B bar, C in bar. So likewise, A bar, B bar, C in. And this is A, B, C in. How am I writing this? All these things you know already, but still I will tell you. This is here, this is your A bar, this is your A, this is your B bar, C in bar, this is your B bar, C in, B, C in, B, C in bar. So you have to club everything, your row and column. The interjunction of your row and column gives a cell value, simply speaking. Okay? So now you have to plot and you have to come out with an expression, simplified expression. So simply speaking, what is this? So first I am going to plot for sum. Sum is 0, 0, 0, 0. To make it fast, I will tell you the shortcut to remember. Look at the value of this. This is a decimal value of 0, 1, 2, 3, 4, 5, 6, 7. If you take the decimal value of these three variables, the decimal value of this is what? 0, 1, 2, 3, 4, 5, 6, 7. How am I saying that? With a code, you know, we have 8421 code to be followed while you are converting your or naming your digital to your decimal. So this is 3 bits. So you have to take 4 to 1. Here all are 0. So no value. It is decimal value is 0. Here this bit is enabled, which is corresponding to 1. So 1. Here this bit is enabled. So the corresponding decimal value is what? Digit is what? 2. So the 2. Here these two bits are enabled. So what are the digits corresponding to it? 2 and 1. So 2 plus 1 is what? 3. So this is how you have to plot your decimal values. Now do remember, for 3 variable K-map, the cell value is 0, 1, 2, 3, 4, 5, 6, 7. So it's a shortcut. Start plotting it 0, 1, 1, 0. 1, 0, 0, 1. Look at this. I have plotted it easily. So do remember this. And do remember, next step is what? Grouping. Here no adjacent cell is common. So I couldn't group it. So I will go for grouping, singular grouping. So what is the sum expression? So first I will start with this. A bar, B bar, C in. Plus what is the name of this cell? A bar, B, C in bar. A bar, B, C in bar. What is the name of this cell or the value of this cell? 1, 0, 0. That means A, B bar, C in bar. Next value of this cell, A, B, C in. So plus A, B, C in. So still, can you reduce? Yes, I can still reduce. 2. If I simplify this expression, finally I will be getting A XOR B XOR C in. In your theory, I have reduced this expression using your Boolean laws. Okay? So that I have told you already. And why we are doing or why expression, reduced expression. In full R-fighter itself, I told you to reduce the number of ICs and the size of the circuit used in your circuit board. So, with this, you have your sum expression. Next, coming for your C out. So, similarly, you have to plot for your C out. That is your carry. Again, I'll make it fast. Okay, since I know it already, it is 0, 0, 0, 1, 0 and 1, 1. Because as I told you, remember, take it as a decimal value and plot it in the corresponding decimal value cells. After plotting it, I could see some adjacent cells. So I can go for a grouping. What kind of grouping? Whether octet is possible? No. Quad is possible? No. So only 2 cells are adjacent. So go for your pair. This is one pair. This is your second pair.